Good morning, everyone. Welcome to the fourth video. This will be on errors and estimation, and as well as calculation of significant figures and relative or random error, fractional error, and what we call percentage error. So all this will be able to do it. Though there is not much to do with the scientific tools available, most of the time it is only calculation. But there are a few calculators which can be utilized or which can be used, okay, to calculate it as a ready reckoner. Okay, this would be useful for students who wants to do some calculation and they want to verify whether they have done it correctly or incorrectly, because your normal calculators will not help you out to do it. So these tools will definitely help them out to work with this. Okay, so let us begin with this. Let me share my screen. See here. Give me a moment. I'm just sharing this. Right. Okay, the first one which most of us we learn while we work on the very first chapter, when we teach the first chapter, is about the relative error calculation. So what is a relative error calculation? Relative error calculation is nothing but if you have a value like x is equal to something like, let me just take up something to show you. Let me take up a PPT. So that I can show you what is that I intend to do it. Right. I share my screen, just a moment. Okay. So relative error. So let us say, for example, if I give you something like x is equal to 3 plus or minus 0.5, and I want to find the relative error or fractional error, so we called. So what we do is we consider this as x0 plus or minus delta x over here, and your relative error, we calculate this as equal to delta x by x. And percentage error, we calculate this as equal to delta x by x multiplied by 100. This is what we do. Okay. Now we are going to do the same thing using your online calculator. But you can ask me like why this is very easy to do it. What is the need for it? But from the student's point of view, this would be more easier for them to do it. You can use a normal calculator, or you can use this also. So for example, I have given you a measured value of 5 over here, and the actual value is 5.6. Now what does this tell you? This is a little bit different over here. So here, what does it tell you is that, so the difference between, so in the earlier case, we did not have a measured value and the actual value, but we wrote it as something like x plus or minus delta x. So here we have actual value and measured value. Difference between this will give you the absolute value, and relative error is nothing but this value divided by the actual value divided by this, and you will get this value. Okay, this is how you can calculate the relative error. You can input the values and you can easily calculate this. And if you want to know more about this, because some students are tech savvy, okay, they learn more, okay, using an online tool rather than something like writing in a class. Okay, and for such students, okay, these kinds of tools would be very much useful. The method how we calculate is being actually given over here. So you can ask them to look at the formula. Okay, maybe we can use this as an FA also to tell them, okay, this is the way how you can do it. Okay, next one is error propagation calculation. So once you get the relative error, then the rest of them percentage error should not be difficult. So this tool helps you out in doing about percentage error, relative error. Oh, I did not share my screen. Just a moment. Right. Okay. So this tool, so it helps you in calculating the percentage error, relative error, and absolute error. Given any value, would be able to calculate any other value. So as you see here, I'll repeat this once again. Measured value is given here, actual value is given here, absolute error is here, relative error is here. Okay. So you can calculate all this, and then if you say reload the calculator, then automatically the page will refresh and you will get the fresh values over here. You can substitute all the values and finally get the answer. So this is how you can get all the three types of errors over here. absolute, relative, and percentage. Now let us move on to the error propagation calculator. When I go to error propagation calculator, as you see here, so what is error propagation? If you have you have an error in x and you also have an error in y, and you want to calculate a value of z equal to x plus y, such that, okay, you want to find out what is the error in z. Then you calculate it using delta z equal to root of delta x square plus delta y square. Okay, so towards it. So this is your addition. You can, in a similar way, you can also have a subtraction, which means what? When I click on this, this becomes z equal to x minus y. If the values of the errors in x and y are known, what do you mean by errors in x and y? The absolute errors. If the absolute values of x and y are known, then you can compute the value of delta z, right? So in each of these cases, you are just computing the value of delta z only. See, multiplication. If suppose if it is delta z is equal to x into y, you can compute the value of delta z equal to z into root of minus of delta x by x whole square plus delta y by y whole square. Then similarly, you can do it for division also. You get the division also. Okay. So thus you will be able to compute the relative error, absolute error, and percentage error. There is no provision for this, but you can multiply that by 100 so that you get the percentage error. Okay. So this is what you can do. So let me just give an example. Let me take up division for example. I will give x is equal to something like 10 and the absolute error in delta x to be 0.1. And in y, let me say this is equal to 200 and this value delta y, I take it as 1 over here. Now automatically it calculates me what is the value of z and the value of delta z, and I have got the value of the, what is that we have got here? Absolute error we have got. Okay. So if I want to do it manually, I need to calculate what is this delta x by x plus delta y by y, this whole square, and then sum up each one of them, take the square root of it, and then finally I need to do it. Of course, in exam, we are not going to use this one. We need to ask the student to calculate it. But okay, what one can do is, okay, we can give a problem, ask them to work it out with this, and ask them to verify it also. Okay, so instead of we sitting and verifying it, okay, we can say these are a set of problems. Okay, you need to show the method, and you also need to do it manually also. Okay, something like a flipped classroom approach also, this will be very much useful. Okay, now let me move on to the next one. The second tool we have seen, relative error we have seen, percentage error we have seen, and how do you calculate the error propagation also we have seen over here. Okay, do we have anything else? No, that's it. Okay, next, let me move on to the next one. Significant figures calculation. This is something we definitely need a tool. While we teach in a class, we clearly tell them what is the rule, how do you perform all these things. But when they go home and then they try out a different problem, sometimes they make a mistake. But whom to ask, they don't ask. And then once again, when they come to us, we will have time to tell them, or they may not have time to ask for us. And as a result of it, okay, they still commit a mistake over here. So this tool is very helpful. I have found this to be very helpul. So what they can do is they can just give any number here. Okay, they can delete this. Let us say, for example, I have something like 1.23506. I have given something like this, and I say I want it in two significant figures. Two significant figures. If it is two significant figures, and then I want the answer. This gives me, let me say, solve. Click on the solve. It gives me 1.23506. The answer is 1.2, right? So this is how it is very much useful. Now let us say, for example, I want something like, instead of this, if I give you something like this, okay, and I ask this for two significant figures once again. So it gives me 1.0, right? So this is how it is very much useful to understand how to solve any significant error problems and significant figure problems are. So this is what it is useful over here. And if you want the theory behind it, it's been given over here. So how to solve, what is the way to get the answer, all these things. They can understand this one, and they can also get us a ready recurrent tool to understand how to calculate significant figures. Now, let me go on to the next one. Random error estimation. Okay. So now, random error, where do we get a random error? When we do lot number of trials, then we calculate the random error over here. So given here are some values. Okay, you can change the values. This is very much useful in case of doing an IA. Okay, so you are given three values over here, and after that, what I do is I say digits after the decimal point should be 1. Calculate the random error. When I do this, I get the answer as mean value is equal to 110, 100, 110, 120. Mean value is 110. Absolute error is 5. relative error is 4.3, so it gives you all of them over here. Okay, so this is how this could be used very much when we are using your IA or E, right? And then last part in this is curve fitting. Okay, this I find it very useful. The most important tools which I find useful is the significant figures and as well as the curve fitting. Now let me clear this. Let me clear this. This is how the interface looks like. This is from PHET. Now what I do is I take up some values over here. So shown here are coins. So what I do is I click on this one here, click on this one. I can click here. So what does it do? It gives you 1 point over here. Okay, note that this curve and residuals are not being enabled. It's been completely unchecked. Now I'll take one more value here. I'll put this value here. Take one more value. Put this value here. One more. Slightly make it curved here. Take here. Put one here. Take one more. Put here. One more. Put here. One more. Put here. And one more. I put it over here. Okay. Now what I will ask is that give me a line of best fit. So what I do is I click on curve here. So what do you think students will do? They'll take these points and join something like this. There'll be a kink over here and they'll draw it like this over here. Many times they make the mistake. Let us click on this. Now I got something like this. It's a best fit. Okay, it's a linear one and it's a best fit over here. I should click on the curve. When I do this one, I get a line of best fit over here. Now when you draw the line of best fit, what do you observe here? See, it is missing this point. Okay, but it is now considering this, but it's not in the center here. It is now considering it's passing through the line through the error bar. This also cuts the error bar. This cuts the error bar. This cuts the middle point. This cuts the error bar. This cuts the error bar. And finally we got it. Okay, so this is what we got. So this is about a line of a best fit over here. Now if I give something like quadratic, then you see a quadratic line of best fit would be something like this. Though this is a line of best fit, but the equation that can be used to describe here would be a quadratic equation. Almost it fits it over here. Okay, so this could be a line of best fit over here. So line of best fit need not always be a straight line. It can also be a curve. Okay, so therefore, so when I say a best fit, see here, this is curve, best fit. You have three options. It can be either a line, it can be a quadratic, it can be a cubic. Whichever is better over there, you can proceed. See, in this example, it has covered all these points except this point. Let me try with cubic also. When I try with cubic also, it is not giving me properly. It is excluding this one, but almost it's covering everything. So therefore, either a quadratic or a cubic would be correct. So if I take a cubic, look at the equation here, minus 0.001 x cube. Okay, which means the coefficient of x cube is so small. Okay, while if I take a quadratic over here, then you don't have a x cube coefficient at all. You have something like a x square coefficient, but still it is not up to that mark, but appreciably this is a bit higher, but it covers all the points over here. Maybe if I give you more number of points over here, this coefficient would have increased. What I will do is let me bring this one here. Let me take up this one here. I will add 2 more points over here. I'll add 1 more point over here. I'll add 1 more point here. Let me add 1 more here. See, as I kept on adding over here, you see this coefficient started to increase over here. Okay, which means it is now telling me that this curve is straight almost until this point, and after that, okay, it is going to converge, or maybe it is going to saturate like this, right? Somewhere it is giving you this information. So therefore, quadratic will really mean something. When I go to cubic back, this value is not changing over here. So as a result of it, I find quadratic to be more appealing. It seems to be more satisfying. Okay, so as a result of it, I'll consider the quadratic equation. But if I go to linear, you see, it misses most of the points over here. Okay, though I can say it's a best fit. Okay, it is not a best fit because it misses most of them. Okay, and you know, so according to me, whenever you say about a best fit, okay, you should be, because we are learning something in physics, you should be able to attribute a meaning to this intercept over here. Y is a variable which you have some physical quantity attributed to it. X is also a variable. Okay, while this one is completely a constant. For example, if it is an xt graph, for example, along the x-axis it will be displacement, along the time axis it will be time over here. But what does this tell you? Okay, so you should put across some variable over there. You can say something like initial displacement, It doesn't matter. But there are conditions where, for example, if this was a graph of current versus voltage, okay, then in that case, okay, at V equal to 0, this I would have been equal to 2 amperes, which is of no use. Okay, so we cannot have such kinds of things over there. You have a series circuit, there's only one battery over there, and if you have at V equal to 0, I should definitely be 0. Okay, you should get an equation Y equal to mx. But if you get an equation like this, then definitely whatever the mathematics is defining, but still, okay, the physics behind the situation is not giving you the correct answer. So this is what one needs to look into it. Okay, so these are the 4 important tools that we looked into it. I looked into it, okay, for solving problems or understanding the concept by visual interpretation or understanding the concepts related to the errors and estimates. Okay, so if you get to know more about those tools, you can write back to me, and my you can see my WhatsApp group. You can join my WhatsApp group on whatever, or maybe if you are subscribed to my channel. Okay, and in the video itself, otherwise also, you can just write down, okay, what are the other tools that you have found interesting. So maybe I can make a new video based on this. So with this, I would like to complete or stop with this video. So do like, share, and subscribe to my channel so that you get more updates. So shortly, my web page is also getting revamped. I'm going to change everything there. Okay, it will not be the same thing. And I will also be notifying you, right, what is the advantage of using this. Thank you very much.